Hey guys, how's it going? So what we're going to do today is we're going to try to extend that concept of finding the area under a curve. And we're going to extend it to finding the area between two curves. Alright? So what this means essentially is that we're going to take a graph, okay, of two different curves. So there's, let's say, f of x, okay, and there's another one. Let's just, for simplicity, call it g of x. I know it looks a lot like f of x, but it doesn't matter. And what we're going to do is we're going to try to find out what this area between them is. Okay? So this is also from a bounded standpoint, right? So that means that we know that here we have a boundary, call it A, and here we have a boundary, call it B. Okay? Now notice that all we're doing is we're doing the area under F, and now we've got too much, right? So what we want to do is we want to get rid of that. Well, that's easy. We'll just subtract the area under G. Okay? So what that leaves us with is that the area between two curves is the integral from A to B of f of x, so the upper curve, minus the integral under the lower curve. Okay? And since these boundaries are the same, AB and AB, this actually simplifies to the integral from AB of the top curve minus the bottom curve, dx. Okay? So this is what we're going to try to use today. Alright? So let's find the area bounded by x cubed and x. Alright, so first let's draw it. And you should also know what x cubed looks like, right? You should know that it's a cubic that kind of comes up here, then turns, and then goes like that. Okay? The question is, so the area bound by these curves is obviously this part right in here, right? Because everything else is not really bound, right? Like this is all, none of that's bound, right? All this is the only area that's bound. Okay? So the question is, what are the intersections, right? Because we want to go from here to here with this being the top curve, and then we want to go from here to here with this being the top curve, right? Because remember, in our formula we always did the top curve minus the bottom curve. Okay? So to find out what these intersections are, what do you think we're going to have to do? Well, if you said that you got to set the two equal to each other, good on you. Okay, so x cubed is equal to x. Now you're not allowed to divide by x. I want you to think about y and bring it back to class tomorrow. But the way that we have to solve this is we have to bring x over to the other side, factor, right? So we've got a common factor. Now can we factor this more? Yep, there's a difference of squares. So x minus 1, x plus 1. Okay? So that leaves us with x is 0, x is 1, and x is negative 1. Okay? So here's x is 0 in the middle, x is negative 1, and x is 1. So now what we're going to do is we're going to start working on our area. Okay? Well, I'm going to call this part here area 1, and I'm going to call this part here area 2. Okay? So area 1. Well, that's the integral from the left bound to the right bound, so negative 1 to 0. And the top curve minus the bottom curve. Well, the top curve is x cubed minus x dx, and the bottom curve is x, so x cubed minus x dx, right? Now, I'm going to let you guys do this integral, okay? And you should come up with the answer that it is 1/4. Okay, so you guys should know how to run this integral and come up with the answer that it is 1/4. Okay, for area 2, all we're going to do is we're going to set it up as the integral from 0 to 1. So this one's going to go from 0 to 1, and the top curve is now x. Right? So this switches. And the bottom curve is going to be x cubed. Okay? So I'm going to, again, let you guys finish that and figure out that it is also 1/4. So the total highlighted area there is 1/2. Okay? So now I want the area bound by y equals x squared, y equals x equals 0, and x equals 2. So let's graph that whole shindig and see what's happening. Okay, so you guys should remember what x equals 0 and x equals 2 look like, right? They are vertical lines, x equals 0, and let's call this x equals 2. Okay, so what we're looking for is we're looking for the area bound by these two curves. This area here is not bound. Okay, this area here is not bound. It's endless, endless. The only bound area is here and here. Okay, so let's do the same thing again. Let's call this area 1, and let's call this area 2. Okay, so let's do area 1 first. Right, that's the integral, and the top function is x, and the bottom function is x squared. Okay, we're going to start at 0, but where are we going to end? Well, we got to find that out. Okay, so again, to find this, okay, we're going to have to do the same thing that we did last time. Okay, we're going to have to do x squared is equal to x, figure out that x is 0 and x is 1. Okay, so this here gives us our upper boundary of 1. Okay, so now let's keep going, and we can find out that from 0 to 1 the integral is x squared over 2 minus x cubed over 3. And we're going to evaluate from 0 to 1. Okay? So plugging in 0, we get 0, and then we have to plug in 1, and we get 1/2 minus 1/3. Okay? So area 1 is 1/6. Okay? I'll let you guys check that if you don't believe me. Now let's do area 2. Well, this time we're going to start at 1, and we're going to end at this line right here. Well, that line is x equals 2, right? So our upper boundary is going to be 2. And now the top curve is the parabola, and the bottom curve is the line. So now we're going to have x squared minus x dx. Okay? So now the integral is x cubed over 3 minus x squared over 2. And we're evaluating from 1 to 2. Okay? So plugging in 2, we get 8 over 3. Plugging in 1, we get, plugging in 2 here, we get 8 over 3. Plugging in 2 here, we get 4 over 2. And then we're going to subtract plugging in 1. So we get 1/3 minus 1/2. So that means that here what we get is 4 over 6 minus 1 over 6. So we get 3 over 6. Okay? And now remember that the area is area 2, which is 3 over 6, plus area 1, which was 1 over 6. So this is 4 over 6, or 2/3. Okay? So here is the homework that I would like you guys to work on if you have time. Otherwise, bring it tomorrow, and we'll take care of it then.